Hello everyone, I am Mohan Krishnan. I am with my team at Mana Venkata Karthikeya. We are going to see a topic about planes classification with example. Going to introduction. Introduction to planes classification. Planes classification is a framework used to categorize computer architecture based on their instruction and data streams. This presentation will provide an in-depth analysis of its four categories: SISD, SIMD, MISD, and MIMD, along with example to illustrate their applications. SISD, single instruction single data; SIMD, single instruction multiple data; MISD, multiple instruction single data; and MIMD, multiple instruction multiple data. I am going to explain SISD and SIMD. My teammate is going to explain MISD and MIMD. Moving on to next slide. Single instruction single data, SISD. Definition: processes one instruction at a time operating on a single data stream. Characterization: single processor execute a single stream of instructions. Each instruction applies to a single piece of data. Traditional sequence processing model typical of order or similar processors. Example: a typical single core CPU with parallelism. It is a SISD. And moving on to next slide. SIMD, single instruction multiple data. Definition: executes the same instruction on multiple pieces of data simultaneously. Characterization: one instruction operates on multiple data elements simultaneously. Useful for tasks needing the same operation on large data set such as image processing and scientific simulations. Requires specialized hardware like vector processor or modular GPUs to perform parallel operations efficiently. Example: modular CPU with vector executions. In that example, Intel AVX etc. or GPU performing the same mathematical operation on many data points simultaneously.
Hi, my name is Karthika and I'm going to tell about MISD and MIMD in Flynn's classification. MISD is multiple instructions and single data, and its definition is multiple instructions are applied to a single data stream, and its characteristics are multiple processors work on the same data, each performing a different operations. And its second characteristics is rarely used in practice as it's challenging to find practical applications. And the third characteristic is more theoretical than real world hardware. And its example is potentially useful in fault tolerant systems where multiple processors independently execute different error checking operations on the same data to ensure reliability. Um, MIMD means multiple instructions and multiple data, and its definition is multiprocessors execute different instructions on different data pieces operating independently, and its characteristics are multiple processors can run different instructions on different data simultaneously. And the second one is it is flexible and widely applicable in parallel computing tasks. And the third one is it is common in multi-core CPUs, distributed computing, and supercomputers. And its examples are a multi-core processor where each core runs a different thread or a cluster of machines working on a different pieces of a complex problem.
Finally, summary table. In summary table, architectures, instruction streams, data streams, example. In architectures, SISD, SIMD, MISD, and MIMD. First, SISD, instruction stream 1, data stream is also 1. Example traditional single core CPU. In architecture, SIMD instruction stream is one, data stream is multiple. Example image processing, vector calculators. In architectures, MISD instead instruction stream multiple, data stream is one. Fault tolerance theoretical. Next, MIMD instruction stream is multiple, data stream is also multiple. Example multi-core CPUs distributing computing. Each architecture presents an unique approach to organizing parallelism with SIMD and MIMD being especially prominent in high-performing computing, while SISD remains standard for basic single-threaded applications. MISD is largely theoretical and rarely implemented. Thank you.